Hi, Tim Graves here again, and now what we're going to be doing is we're going to be looking at how we can use Helidon to dynamically generate OpenAPI documents. Now, firstly, you may be wondering what OpenAPI is. This is basically the new name for Swagger. Okay, so if you ever previously had a Swagger configuration file that describes what your API looks like, this is what can be generated using Helidon. Now, one of the questions is, why would you bother doing this? Well, there's a number of reasons why you might want some kind of automation to generate what is effectively the definition of your service. Okay, it may be that you want to automatically generate a client. Now, Helidon, as we've seen, can use the REST client model to create client instances, but it may be you're dealing with a language other than Java, or you're using a client framework other than Helidon. So you may have automated tooling that will generate your client code for you. Another example may be that you've got some kind of automated front end to your cloud services that will ensure that the data that is processed actually already meets the specification of the API. So there's a number of reasons why you might want to do this. Now, why would you want to do it automatically, however? Really, that's just to save time and effort. Obviously, if you're maintaining a separate document, you have to keep that in synchronization with your code. If, however, your code is self-describing in that respect, then you can just change the code, and as you're changing the code, you're automatically updating the API. So how does Helidon do this? Well, it uses a bunch of libraries, OpenAPI libraries, that are part of the Helidon build code, and it then goes and uses those libraries to interrogate something called a Jandex file. Now, Jandex is something that you've kind of been looking at already, though you may not be aware of it. So Jandex is a Java index. It helps you understand what classes you got, what methods, what annotations, and so on. So when we put OpenAPI documents or OpenAPI annotations in our code, when we generate the Jandex file, this will automatically be done for us. Now, the Jandex file is something that is done for us by the Maven build process. However, at least for Eclipse, this isn't something that's automatically created. The reason being that Eclipse rebuilds your environment every time you save a changed file, and creating the index may slow that process down. So this is a Maven type feature rather than something that's built into Eclipse. You could, of course, have Eclipse do this if you wanted to, but your save processes would get significantly longer. So let's have a look at what we can do here. Now, just to show you to start with, if I just run this little piece of code. So if we go and have a look at our OpenAPI environment, so we've just got a basic piece of information saying, yes, there's an OpenAPI endpoint here, and we can see a bit of information, but there's no other real information there. So let's go and start defining the service itself. And at this point, we're going to explain why we have been using main classes and the storefront application file rather than using Helidon to generate these for us. And the reason is that we want to put these annotations onto the application. And we can't do that if we don't have an application class. So what I've just done is I have just applied an annotation in place here. This is the OpenAPI definition annotation. And we've given it, say, what's called an info block, which basically describes what our program looks like. So it's saying it's got a title, it's got a little bit of a description, and obviously a version number. So this is absolutely brilliant, and we can save this file. Now, I said earlier that we need to generate a Jandex file. This is done by Maven, and the Eclipse Maven plugin that does builds kind of Maven-like, built into Eclipse, doesn't do the Jandex processing. So what we need to do is we actually need to do a Maven build here. So this is a little bit of a more time-consuming process. Effectively, it's just going to scan the classes. In this case, we've only changed one or two of the files, and it's going to create this index for us. If we now run our file, run our class, and go back here, and let's go and get a bit more information. So we're going to access the OpenAPI endpoint again. And you can see now there's a lot more information that's come back. That's because the Jandex has actually generated this index for us, and that's automatically generated all of the endpoints for us. You can see there's quite a lot of endpoints in here, okay? But we can see our little piece of information that we specified earlier is now available to us. Now, strictly speaking, what we've done now is all that we need to do to be able to correctly validate the code. But it doesn't, for example, tell us a lot of useful information. Yes, there's an endpoint called minimum change, but what is it? What does it do? Perhaps that shouldn't actually be a documented endpoint, for example, as part of the API. So what we want to now start looking at is how we can control the information that is included in here. Okay, so the information we've got at the moment is pretty basic. Now, there is additional information here. I have already annotated the item details and the item details class, so you can see the description and stuff like that. That was done previously. But let's go and have a look at what we can do in terms of annotating the item request class. Okay, now the item request is the information that we can pull out that explains what we're going to do here. So I'm just trying to find my sample code here. Okay, so we're going to specify what that looks like. All right, now we go back in here and we find our item request code. First of all, we're going to use the schema annotation to say this is an object type item request. This is what it does. But we're also going to put a couple of annotations on the fields themselves. So we're going to describe again using the schema annotation. This is the name of the item that's being annotated. It gives us a little bit of example. And this is the request field that will tell us what it looks like. Okay, so in other words, how many of the item we have asked for. Okay. Oops, I put that in the wrong place. Sorry. Oops. Let me try this again. Copy that one. So count of the items being requested, and we'll give an example, say 5. Okay, we don't have to specify that this is an integer because, of course, we know it's an integer because we can tell from the field here. Okay, so given we've also got a couple of Lombok annotations, we've now got all of the constructors and getters and setters being created here. So if I now save this, and if we run the code again, okay, what that's going to do is when we access it, we will see that now our item request details explain. Oh, sorry, I do apologize. I should have rebuilt it before I ran it. So let's go and do the Maven build process on the project. Then we can run it. Joys of recording a live demo, as always, it never works exactly the way you think it's going to. So now if we go and run that class and we can look back, we can see the example and the other information that we've provided there. Now, that's great. That provides us with a lot of useful information, but it's quite possible that actually we don't want to include all of our resources here. Okay, so the minimum change is probably something that's an administration resource rather than something that is a end user thing. Okay, so especially considering now we've made the minimum change something that can be controlled via the REST endpoints or a configuration file, we probably don't want to do that. So what we're going to do is we're going to go and change our configuration file. Now this is something that's used as always by a number of services, and we're going to have a look at the API generation. And what I've done here is I've already actually put the request in place, so I'm just going to comment it out. But basically what I'm saying is when you're scanning for OpenAPI requests, exclude this particular class, which is the status resource and the configuration resource classes. Okay, You could, of course, include others as well, but we're basically saying, yes, they're there, but I don't particularly think that that's useful for an end user to have access to. Okay. Now, in this case, I don't need to rebuild the index file because that's basically already been built, and this is a runtime annotation rather than a compile time annotation in terms of runtime configuration option against a compile time annotation. So now if I go in and run this, you can see that yes, we've got the stock levels requests, but we don't have the configuration request, we don't have the status request. So effectively that lets us control what our service is delivering and displaying. But what we're not doing here is we're not actually explaining what that looks like in terms of the describing the elements of a service. Perhaps what about some of the descriptions of the methods themselves? So let's now go and have a look at those and how we would process those. So if we go back to our storefront resource code, okay, and what we're going to do is we're going to have a look at the list all stock method. Now this is a large chunk. I'm just going to paste it in place to start with, and then we will explain what it does. Oops. Come back here. So here's the list all stock method. Okay, so first of all, we define the operation. So this lists stock items and it returns a list of the stock items that are currently in place. Okay, so that's a nice quick description. Then we say what the response is. Right now, obviously to start with, the response is a set of items representing the current data in the database. That's great. But let's have a look at this. So what we're now going to do is we're going to say the response code is 200. That means it's successful, and if the response code is 200, this is the content that is returned. It's a set of details of item class in an array, and it gives us some examples of what that array might look like. Okay, so if we save that and rebuild the index, and then run it, okay. So now if we look at our class, okay, you can see here we've got a whole bunch of additional stuff. So if you access the store stock level, it says that if you do a 200 response, you are going to be getting back something that looks like this. It's the number of items. That's what each item looks like, and the various fields that are in there. We could put additional information here about, for example, the limits, if we wanted to limit it to always greater than 0, for example. Okay, so extra piece of information there, but there's other things that we can probably do here. So one of the other things that we can do is we can let's have a look at the reserve stock method. So, okay, let's go in and add this to the reserve stock method. Now here, of course, we have to define not just the inputs, but also the output. So first of all, there we've said what the inputs look like, but I'm going to add additional content to the request. So basically saying this is what the incoming request look like. Now I appreciate that this is now getting an incredibly complicated particular system to look at. So if we save that, hopefully it might, no, it didn't reformat it. Okay, so let's just quickly return that to give us a little more information. So basically the request body, this is the description of our request, tells us what it is, tells us that it has to be there, because obviously it might be optional, tells us what the class is, and some example code. Now, effectively what will happen if we save this and again rebuild the index, and then we can run our class. If we go back and have a look at that request again now, what we're going to see is the additional information on how to process the request, okay? And you can see it also describes the content that you need to include in the body to process that request. Now, you're going to say, well, why is that not saying this is the method? Well, because the method is effectively something that Helidon does, right? In practical terms, when you're making the REST request, the arguments that are unmarshaled, by Helidon and converted into the object that's then handed to the method, those are embedded in the body of a request. Now that could be processed in other mechanisms. So that's why it says the request body rather than being this is a method argument. Okay. Now, of course, so far what we've been doing is we've been looking at how to handle a specific response. Now, our code, of course, is going to potentially deal with a number of other responses. So let's go and put some of these other response types into our code here. Okay, so that is the response type if you request it and it works. But let's have a look at the other response types. Okay, and effectively what we're saying is you're going to get a 404 if the item doesn't exist. You're going to get a 409 if there just aren't enough available, and you're going to get a 406 if you've got an error. In other words, if the information is incorrect. Now, strictly speaking, you can obviously choose how these would map on to the appropriate error codes. I've tried to choose appropriate HTTP error codes that would make sense in that context. All right. Let's save that away and again rebuild it. And then run that. So now we have a list, all right? There's not enough items to fulfill your request. You haven't met the minimum change. The item doesn't exist, so 404, not found, all right? You will generally find if you search the internet, there's some guidelines on the internet as to what HTTP code you should use as a comparison to the underlying code, right? Clearly you can choose these yourself, however. So this is showing you quickly how you can effectively create self-documenting code. Obviously, I may change the code. I may add extra exceptions or extra processes or extra items. Okay. In this case, the error codes 404, 406, 409 actually come from the way that I am processing the error responses in my fallback handler. So my fallback handler basically says, if you've got a minimum change exception, i.e. there's not enough, then this will translate into an unacceptable request. Okay, so that I think is the 406 error. And the other codes also fit in there as well. Okay, so that shows you how to use the OpenAPI documentation. As usual, if you want to have a look at the template code, the rest of the lab, there's instructions coming up right now. What you've just seen is based on a lab which goes through effectively using Helidon to create microservices from a monolith piece of code. This lab is available to anybody on the internet. It's originally written to work in the Oracle Cloud, but you can take the source code from the Git repository and run it in your own environment. You can use a MySQL database or other databases if you want to. So what I'm going to do now is quickly show you how to get to the lab. That will include links to where you can download the original template source code and obviously the content of the lab itself. So in a web browser, if you go to bit.ly/go live labs, okay, and that will take you to the Oracle Live Labs starting page. Then search for using Helidon to create microservices from a monolith. Now that's going to return two lab options. The overall sequence of videos is based on the extended lab version, but if you don't want to do the extended stuff, you can just focus on the shorter version. You basically just click the launch button. And then if you want to run it on an Oracle trial, you can register for a free trial environment. If you already have a free trial environment, you can then look at running it within that environment. You just basically click on that. You can then have access to the web page. Effectively, what you need to do, follow the instructions under getting started and set up your tenancy and set up for the Helidon labs to get this working in the Oracle Cloud environment. Now, if you don't want to use the Oracle Cloud environment, then there are instructions on how to download the source code using in the setup for Helidon Labs section. You'll obviously need to make sure that you've got Java 11 on your laptop. You're going to need to make sure that you've got a suitable IDE and so on. If you want to use a database other than the Oracle database, you can do that, but you'll need to configure the database files so that you can ensure that it will work on the local database, and that's basically through the JDBC and JPA, JTA settings in the meta-inf folder. So thank you for that. Hopefully you will enjoy playing with that, and good luck.